Hello everyone, welcome back to Educately Geography. Today we're going to be talking about the different types of rocks. So let's dive in. Today's objectives, first we're just going to outline the differences between sedimentary, igneous, and metamorphic rocks. And then we're just going to talk about the rock cycle, which is just how a given type of rock can transform into these other types based on natural processes. So yeah, first let's just talk about what a rock is. It's good to have like a nice definition that we can fall back on. A rock is best defined as a natural and coherent mass of at least one mineral or some sort of organic substance. They can vary greatly, as I'm sure you're aware, in their actual composition, but we can still divide them into groups based on how they formed. And there are three main groups that we usually divide them into. First is igneous rocks, then we have sedimentary rocks, and then we have metamorphic rocks. So first, let's talk about igneous rocks. An igneous rock is formed from cooled and solidified magma. Magma is just melted rock. So once that melted rock, like a rock melts, and then once it solidifies again, we classify it as igneous. The texture of an igneous rock depends on like how fast it cools, and that rate of cooling, it really depends mostly on one factor, and that's where it cooled. Intrusive igneous rocks, these are rocks that cool and solidify underneath the Earth's surface, and they tend to solidify at a much slower rate. The conditions down there, it's a lot harder and less forgiving for rocks to solidify, and that allows large crystals to form. Meanwhile, you also have extrusive igneous rocks that solidify above. X means out, so out of like above the Earth's surface, and these solidify a lot quicker than intrusive rocks, and as a result, they don't have time to develop these crystals. They're a lot finer. Sometimes it takes them seconds to solidify, in which case they're almost like glass, like glossy. Also, these extrusive igneous rocks, they often have vesicles, which are just gas pockets. The reason that they have these is, say that you have a volcanic eruption and like lava's flowing out of the volcano. Once that lava solidifies, sometimes it happens very quickly. Lava usually has gas bubbles in it, just because. And once it solidifies, those gas bubbles, that they don't really have time to just like dissolve. Sometimes they just kind of get stuck in that solidifying pattern, and like they just have like kind of like bubbly patterns in the rocks because there were bubbles there. So like once it solidified, it just kind of got preserved. So yeah, enough about that rant. Let's just look at this illustration about intrusive and extrusive rocks and like where they form. Again, intrusive happens within the Earth's surface. This is the surface right here, and extrusive happens outside the Earth's surface. This is an example of a volcanic eruption. And yeah, extrusive rocks, these form from like lava that solidifies. This forms from like magma underneath the surface. So yeah, and obviously these take longer to solidify because of the conditions. And then we have this illustration about intrusive and extrusive, what the rocks actually look like. You can see from this intrusive rock, you can kind of tell, I think if you especially have a good knowledge of rocks, you can tell that this is going to be intrusive. If you know that it's an igneous rock, because you can kind of see like the crystals that are on it, like the crystal-like things. So that's like an indication that it took a while for this rock to solidify from magma. Then you have this extrusive rock, which you can see like these bubble-like things. Again, it's like it was lava and then it solidified so quickly where like the kind of like the imprints of like the bubbles, they kind of got preserved in the rock. And that's obviously a feature of extrusive rocks, igneous rocks, but like also you can see that it's pretty fine outside of those bubbles. It's a pretty smooth rock, at least compared to this one. No real crystals. That's going to be extrusive. Next up, we have sedimentary rocks. A sedimentary rock is like an accumulation of like minerals and or organic material into like one solid mass. It can be mineral or organic. We'll talk about that in a second. And I think a good way to picture like the formation of sedimentary rocks is to just think about just tiny bits of sediments, like pieces of solid matter. Just rocks is like little pebbles I think is a good example, or like sand. They kind of just gets carried away and then eventually kind of gets like deposited on like say like a beach or like somewhere. And over time, more sediments will kind of pile on top of those sediments that first got put down or deposited. And once you have enough weight over like the original sediments, it's gonna kind of start compacting together. There's gonna be enough weight where it's gonna start kind of getting into like a solid mass, and that's known as compaction. Then you also have the process of cementation, where you have liquid that kind of causes that these like mashed up sediments and compacted sediments to just like mush together into like an actual solid rock. And that entire process is known as lithification. That's like at the backbone of how these sedimentary rocks form. They also often form in layers as well. I'll show you in the next slide. We have a good illustration of that. There are three main types of sedimentary rocks. These types of rocks, like, even though these are divisions, there are often subdivisions of these, as we saw with intrusive and extrusive igneous rocks. These are really based on the types of things that are included in sedimentary rocks. First, we have clastic sedimentary rocks, which are derived from eroded sediments. This is really good with the example I just mentioned. So it's like things from, like, you can say, like, inorganic rocks from, like, cliffs and, like, the side of a river, like these things that don't really include the things that I'm about to talk about. Just like regular pebbles, I guess, and like rocks and like sediment that kind of just gets mushed together. And obviously these other ones also include sediments, but I think you'll see the difference when I talk about it, because organic sedimentary rocks, those are compacted animal and plant remains. Notice with plastic sedimentary rocks, we just have like inorganic things, not things that weren't ever living or never a part of a living organism necessarily. But with organic sedimentary rocks, we have animal and plant remains. For instance, coal. I'm sure you're aware of what coal is. Coal is basically just it's derived from decayed plant matter. You also have chemical sedimentary rocks, which don't necessarily include organic substances, but they form as precipitates in solution. So basically, a good way of picturing this is you have a cup of water and you put a bunch of salt in it and you stir it up. And then eventually, like, that salt is going to dissolve in that water. You're no longer going to be able to visually see it. But if you like leave that cup out for a few days, that water is going to evaporate. But the salt doesn't evaporate with the water. That's not how chemistry works. So eventually that salt is just going to start reappearing visually in the actual water. And once all the water is gone, it's just going to be a bunch of salt. And that's basically how most chemical sedimentary rocks form. It's really just like, they're known as evaporites, and they just kind of come as like solid things that are seen within water. And once that water or like that liquid evaporates, it just kind of appears. Obviously, it goes through the process of like compacting and cementing into like a solid coherent mass if you want to get them in like a large mass. But yeah, they can also be pretty grainy, and that's what happens if they aren't necessarily compacted that well. Okay, so this is a good illustration of the layers I was talking about. You can see that there's like different bands that appear. You can see one red one, then a few brown ones. Like, you can kind of like intuitively tell that like this substance is going to be like very similar to like one another compared to like this substance, like kind of like different things that are like in those bands. And obviously, that like the older ones are going to tend to be towards the bottom, and then like the newer ones were just more recently deposited. Those are going to be towards the top. So types of sedimentary rocks, these are the three main types we just talked about. This one right here is a clastic sedimentary rock. You can kind of see like the little bits of like pebbles and like sand and things that have been like kind of mushed together. So right here we have a chemical sedimentary rock. This is like I'm not sure what the exact type is, but this formed from the same chemical process I mentioned earlier. Most likely from evaporating, liquid, and then it just kind of like formed as a precipitate in the remaining liquid. And then here we have the other type of sedimentary rock, an organic sedimentary rock. This is an example of coal, as I mentioned. It's from decayed plant matter that's organic, what used to be living or part of a living organism at one point. So the last type of rock is metamorphic rock. And a metamorphic rock, it's like a previous rock. Like, it can be any type of rock, metamorphic, igneous, or sedimentary, that's changed due to added heat and pressure. And there's two real ways that like these rocks can metamorphosize. The first way is contact metamorphism, and this happens when nearby magma, it like burns rocks, which causes their composition to get modified, but it doesn't actually melt them into magma, it just burns them. That's a good way to think about it. Then you also have regional metamorphic rocks. Regional metamorphic rocks, like regional metamorphism, it happens when you have increasing pressure that causes rocks to get smushed enough where they change in like their actual composition. And I think the most common way this happens is when you have converging tectonic plate boundaries. Because as you can imagine, if you have two tectonic plates, like these massive things that are just colliding into one another, it's going to create a lot of pressure, especially near the site of conversion, and those rocks are going to kind of get modified as a result of that. You also see foliation with some metamorphic rocks. These are stripes and like bands that occur, different from the ones we see in sedimentary rocks, but it happens usually as a result of regional metamorphism, where you just get so much pressure where it kind of rearranges the minerals that are within a rock, and that causes these different bands to appear. And we have a good illustration for that coming up. I think this illustration is good for seeing the difference between contact and regional metamorphism. You can see that we have a volcano. We have two converging tectonic plates. That's how most volcanoes form. You have this magma that's oozing through, and then it has like a magma. We have a magma chamber right here, and notice that magma is just melted rock, but around it, we kind of have, around like the magma, we have like rocks that are heated up by it, because magma, of course, is very hot. But notice that these rocks aren't melted. It's not hot enough there where the rocks are actually getting melted into magma, but it's just getting modified. That's what metamorphism is, specifically contact metamorphism. It's happening as a result of heat. We also have regional metamorphism shown in this illustration because we have two converging tectonic plate boundaries. That creates a lot of pressure around, like, near the site of, like, near the tectonic plate boundary. And I think we have a good illustration on the next slide, but that just creates pressure that just modifies the rocks that are nearby. Similar to contact metamorphism, except it's caused by pressure, not necessarily just by heat. Usually you have a mix of it though. So yeah, it's usually more complicated than that. This is a good illustration of foliation, like the appearance of bands in metamorphic rocks. First imagine you have like this type of rock, just like as it says, the minerals are randomly oriented into like this nonsense, different. It seems random. But say you have like kind of like pressure like applied in, like, in this case, both directions. It's like you're like kind of squeezing it, like obviously like very, very hard, because this would happen like underneath the Earth's surface, with like tectonic plates. It kind of causes that these minerals to like arrange like into like a parallel way, parallel to one another as a result of that stress. Usually it happens perpendicular to that stress, you can see. So yeah, that just happens naturally. That's how foliation occurs. I think a good way to summarize this video is looking at the rock cycle. It really tells you all you need to know about these different, like the relationship, I guess, with these different types of rocks and like how one can change into like a different type. We can go through it together. Let's start with sedimentary rocks. So you know that if you have a sedimentary rock, it can kind of like, if you apply heat and pressure to it, as I just mentioned, it turns into a metamorphic rock, and that's how metamorphic rocks form. But that metamorphic rock, if you add even more heat to it, to the point where it melts, it turns into magma. And obviously, what happens to magma once it solidifies? It turns into an igneous rock. And then once you have the igneous rock, it can do a lot of things. You can melt it back into magma, in which case it just continues that cycle, I guess. You can add heat and pressure to it. If you're talking about heat, it's going to be enough heat where it's going to get modified, but not enough where it's going to actually melt. So it's going to be a metamorphic rock again. Or you can do weathering and erosion, which is basically just over time, just things, it kind of just chips apart because of like, all sorts of different things like weather, like water and things like that. You can kind of weather and erode into like sediments. And once you have those sediments, it compacts and cements. We talked about lithification earlier. It can do that into like sedimentary rocks again. Kind of just research the process. Obviously, sedimentary rocks can once again weather and erode into sediments. So yeah, you kind of just have the cycle. I suggest if you haven't taken it in, you can always pause it. I'm sure your teacher will go over this. It's very important to understand the actual way that these rocks, function. And it's really pretty much summarizes everything also, like the way all of these different rocks form. So that's a good way to end this video. So yeah, thank you for watching. If you need any more help with geography itself or like other middle school subjects, feel free to browse through our site. But that wraps it up for today, so thank you.